Welcome to today's class. Today we are going to discuss about Newton's law of gravitation, gravitation constant, and this formula F equals to g m1 m2 by d square, which you have been familiar in the previous class, and also you have solved the numericals from this formula, and also I have told you to memorize the value of gravitation constant, which was given by Henry Cavendish, though the law of gravitation was given by Newton. So this will be today's lecture will be based on these three things. Now before learning to this Newton's law of gravitation, let us be familiarized with mathematics and some mathematical term needed in physics. Here is one equation: W equals to mg. You know W is weight and m equals to mg. Now to change this equals to into directly proportional or inversely proportional sign, you should remove the constant. And as you know, if you take 5 kg mass in Nepal, India or anywhere, it will be 5 kg. So generally it is believed that this mass is a constant quantity. If mass is a constant quantity, then what we can write? W is, we are using this sign, and W is directly proportional to G. It means that weight is directly proportional to acceleration due to gravity. Since the value over here is in numerator, G is in numerator, so we call this sign as in directly proportional. And what you can say, weight is directly proportional to the acceleration due to gravity. Second, G equals to gmm by r square. If G and m are constant, then we can write G is G same, and we are using the same sign, this sign, by r square. Just we are changing equals to into this sign, and we can understand from here gm. Since G is constant value 6.67 10 to the power minus 11, mass of the earth is also a constant. That's why we are getting G is inversely proportional to R square. Why we are saying inversely proportional? Because R square is in denominator, here G is at the numerator, so we are saying directly proportional, so we are saying here indirectly proportional. Also we can understand that if R increases, what happens to G? Inversely proportional means G decreases. Similarly, if R increases, if the radius increases, then we can decreases, then we can say G increases. It means that they are inversely proportional. So from here we learn that we can change equals to signs into inversely and directly proportional and get the mathematical concept behind it. Here also in the same case, if G increases and W also increases, because it is directly proportional. If G decreases and W also decreases. And let us see the same formula over here. We have learned F equals to G m1 m2 by d square. From here it is clear that this G is a constant quantity. G is constant quantity, that's why I can write F is, I'm changing this sign, and I'm using this proportionality sign, m1 m2 by d square. So I'm again breaking, these are in numerator, these terms are in numerator, so I'm using F is directly proportional to m1 and m2. Again, this d square is in denominator, so I am using F is inversely proportional to 1 by d square. Now what I can say, force is directly proportional to the product of masses, and force is inversely proportional to the square of distance between their center. Generally here we are understanding from this equation into these two signs, and here from here we can understand, if masses, product of masses increases, force also increases. If the distance increases, and force also decreases. From the above understanding we can use in the same way. Now let us recall what we call F. F is called the force of attraction. And from these two equations, using these two equations, now we are stating the Newton's universal law of gravitation. Here should be gravitation, not gravitational. Here should be gravitation, Newton's universal law of gravitation. And you can use this word in your own, but never forget to mention the product of masses and inversely proportional to square of distance. So I have written in this way: everybody in this universe is attracted with each other by a force. It means if any two objects are whole in the whole universe, if there are two masses, then they are attracted with each other, because Newton's law of gravitation force is attractive force. So the force of attraction between any two body is directly proportional to the product of masses and inversely proportional to the square of distance between their center. So now I think if you know that formula, it is very easy to state universal law of gravitation. You can say that uh, universal law of gravitation states that the force of attraction between any two bodies is directly proportional to the product of masses and inversely proportional to the square of distance between their center. Uh, so your main answer is from here to here. This is the main answer. No need to write everybody in this universe attracts each other body by a force. Just this is the main answer, and you are getting the main answer from here. F, this is attractive force. The force of attraction between any two masses is directly proportional to the product of the masses and inversely proportional to the square of distance between their center. From this definition also we are able to state the Newton's universal law of gravitation. And moving to next slide, and now from here the question says prove the relation F is equals to g m1 m2 by d square. Now to prove these relations we are using Newton's universal law of gravitation from the and just take two mass. These are two masses, and these are the separation distance between the center. We should always take from the center, and the distance is called d. Now you can say that from Newton's universal law of gravitation, the force of is directly proportional product of masses inversely square of distance between their center. Just I have mentioned the Newton's law of gravitation to prove this one. Now let us consider two masses here. The mass one is we have denoted m1, and the second mass we have denoted m2, which are separated by a distance. These are separated by a distance d. So from the first part of Newton's law of gravitation, we can write F is directly proportional to m1 and m2, because it says the product of masses. Force is directly proportional to the product of masses, means product of two masses m1 and m2. And similarly, the second part of Newton's law of gravitation says that force is inversely proportional to the square of distance. So F is directly inversely proportional to 1 by d square. That's why F, now combining this 1 and 2, you are getting F is this, we say proportionality sign m1 m2 by d square. Now to change this proportionality sign into equation, we have to introduce a constant. I have told earlier we have to introduce one constant, and this so F equals to g m1 m2 by d square. This constant g is called proportionality constant, called gravitational constant. Till here now I think you are understanding that we are just discussing about Newton's law of gravitation, F equals to g m1 m2 by d square, how we are getting this formula. I have started from here because if you know this one, it is easier to understand. No need to memorize rote memory of Newton's law of gravitation. That's why I have started from here. So this is the overall serial form that I have mentioned, universal law of gravitation, and after that F equals to g m1 m2 by d square. Now we have to define this constant. What is gravitational constant? Or it is also said universal constant. Why the gravitational constant is called universal constant? Because it is applied whole the universe, all over the universe, not only in the earth, not only in the Mars, not only in the sun, all over the universe. That's why it is called universal gravitational constant. And another thing to be noted down is This is quite important formula. Sometimes they will ask you to prove this formula in exam. It consists of 3 marks questions. Prove F equals to gm1 m2 by d square. Now you have to define a gravitation constant. Now we are thinking about the previous scenario. Just we are taking one mass, second mass, and the distance d. At that time, the force of attraction between these two bodies is F equals to gm1 m2 by d square. We call this is called force of attraction or force of gravitational force. And second, overall, now we have to define this g. Now use your mathematics. How do you find the value of g? Now arranging that equation f d square, just cross multiplying that equation, f d square equals to g m1 m2. Okay, g m1 m2. Now what is the value of g? Where you should familiar with every term. F is the force of attraction or gravitational force. D square, d the distance between the center. M1 m2 are two masses, and g is the gravitational constant which we have to define. So let us think about this scenario. From here g, you are getting this value, g equals to f d square m1 m2. Now think about this scenario. Take 1 kg mass, and this side also 1 kg mass, and make the distance between them as 1 meter. Then put all this value over here. F into d square means 1 square, that is 1, and by divide 1 divided by mass means also 1.1. Overall you are getting the value as F. Okay, you are getting the value F. Now how do you define gravitational constant? Now see, the force of attraction between two unit mass or two 1 kg mass which are separated by a distance of 1 meter. So this is the easy definition. And if you find the constant in that way, if you introduce a constant in that way, and we'll define in the same manner. There will be 2-3 definition in physics in your level, which you will define in the same way. Gravitational constant is the force of attraction between two unit masses which are separated by a 1 meter distance apart. Now this is how you are defining gravitational constant. Now here are some objective questions. I think it will be quite easier one. G capital G denotes for gravitational constant. Its value is 6.67 into 10 to the power minus 11 Newton. Now to know the units of this gravitational constant, from here you will know. To know the unit, gravitational constant means force unit is Newton. You know that one. And d square means meter square. Its unit meter square divided by kg square, because there are two mass. Now you can write this equation in this unit as in Newton meter square per kg square is here. You can write kg minus 2. It means it is in divide. When it comes upward, this is the unit of gravitational constant. Now its value is standard one, that is 6.67 into 10 to the power minus 11 Newton meter square per kg square. And there is one question, it is asked one time in exam. The value of gravitation constant is 6.67 into 10 to the power minus 11. Now copy the same unit over there, Newton, and it is a standard value, we know that one, Newton meter square. How we got the value is by placing all this 1 kg mass, and they separate one distance, and they try to find out the value of force, and it is they found this one. And I think they have done in a very sophisticated lab with high precision value, and that's why they got it. Kg minus 2. Now what does it mean? Gravitation constant G value equals to gravitation constant value equals 6.6 into 10 to the power minus 11 Newton meter square kg minus 2. What does it mean? Now if you get that question, you can say that it means that 6.67 into 10 to the power minus 11 Newton force is held when two masses 1 kg, two 1 kg masses are kept at 1 meter distance. It means, I think you understood. You can say that when two unit kg masses are kept at 1 meter distance, the force experienced by the masses is 6.67 into 10 to the power minus 11 Newton. Don't copy all the units because the force we are talking about just force, so this much force is experienced when two unit kg mass are separated by a distance, so it will be quite easier. Now second, what does W means? W means gravity. Yeah, and also you should know that if this is earth and if here is 10 kg mass, we can say weight equals to mg. Don't forget to write that one. Weight equals to mg. It means if the object is over here, it also, because in the next lecture you need that one. If object is here, it tries to fall towards. Let me zoom in, zoom. Let us take the example of earth, and if this object is over here, it will fall towards the center. This is the surface of the earth where we are living, and it also falls towards the center. It will fall this, the direction is given. If the object is over here, it will fall towards the this side, and if the object is over here, it will fall towards this side. And if you say what is the weight or gravity, gravitation force, don't write g, I am writing using w. Gravitation force is g, and we should mention one mass of the earth, m, by g. This is the mass of earth, capital M, and I'm changing the in my ink, and 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 let this mass be small m, by distance between them. Generally we write r square. No, here sometimes we can use r plus h whole square also. H generally defines the surface from the earth, r square. Okay, now this is the weight. Now you can say what is the gravity? The force of attraction between the planet and a small object towards its center. It falls towards the center. So you might need in next class, so I told this one. What is the F symbol denote? Gravitational force, not gravity. W is gravity. Yeah, on what factor does gravitational force depend? Now you know that the gravitational force formula is F is directly this sign, we call proportional this sign. Don't write the G. Proportional, m1 m2, m1 m2, the product of inverse proportion square of distance. Yes, it is correct. Proportion, then all of the above, this might be the answer. This should be the answer. What happens to force decrease, and what happens to F when mass increases? Mass increases means if this mass increases, the force decreases, the force also increases. Force also increases. This is the answer. What happens to distance increases, to the force decreases. Overall, I think you have done the overall lecture over this thing. Thank you for listening. Try go through this one, copy, write every note down in your copy, so that it will be helpful to you, because you might lose all the pdfs, or the thing you have understood you might erase from your brain. So note it down in your exercise book. Okay, thank you for listening.